Hello guys, welcome back to Mezon African Motives, still on our Mechanotechnics and 5, working on revisions. So in this case, we have a question paper that we're gonna consider from November, that is November 2022 exams, whereby we are dealing with bucket elevators and bucket conveyors in this case. So let us roughly go through the questions. The 3.1 was to state a function of the tensioning device fitted to a bucket elevator. So if you consider the sketch of elevators, we have a tensioning device which is actually used for compensation for variation in length of chain or belt due to temperature changes, atmospheric condition, or even the wear and tear. So that is the purpose of the tensioning device in this case. So we can just say compensate is to compensate. So we are going to compensate for variation in length in this case, for variation in length of chain. So those variations now that are found on the chain or the belt in this case, what causes the variations? That is what we are saying due to temperature changes. So we're gonna need temperature changes and also the atmospheric conditions. All right, which is just the same as the temperature there. Atmospheric conditions. Temperature is also involved there, but here we talk about being the humidity and so forth. Or we can consider the wear and tear in this case. So there are so many things that we can consider them. All right, then with 3.T, we have got the information that we are given. The following details apply to a bucket elevator used to transmit cold. So it is used to transmit cold in this case, and this is the information that we are given. The center distance between the head and tail pulley is 90 meters. So we are given the center distance in this case. Remember the center distance, that's C in this case. Let us just take our given information or the given data in this case. So C is given as 90 meters. Then we also have the bucket spacing in millimeters. So convert this to meters. If we divide by 1,000, we're going to have 0.794. So we've got the spacing in this case, that is the spacing of 0.794 in meters. The spacing is supposed to be in meters, the distance between the points, the chain speed. All right, so this, if we are to take note, we are actually limited on the speed that we are given here. Remember, they are saying it's revs per minute. If we had to take note, if we had to find this, it's supposed to be V, it's a pi dn over 60. And in order for us to have this d that we are seeing here with the diameter, we are supposed to take it from the velocity. We can only use it if we have the velocity in meters per second, which is the square root of, in this case, remember we've got g times the cosine of theta times the radius, where you can use the radius to calculate d. But we need this velocity. So meaning to say this was an error that we see. It was just a typing error. The information that we have here, it's limiting us to use the revs per minute. This was supposed to be meters per minute. We are given the chain speed as 80 meters per minute. All right, so this is 80 meters per minute. So you're supposed to convert to meters per second. We divide by 60 meters per minute. We divide by 60. So it's going to be 80 over 60 in this case. So 80 over 60, that is going to give us something like 1.33 3 something like that in meters per second. So it's supposed meters per minute there. All right, so that's our speed, 1,333 meters per second. So we have got velocity v, speed in this case 1,33 meters per second. All right, then again we are given the mass transported in an effective shift time. So we're given the time when the mass of 1,300 ton is transported. So it's mass per unit time. So we are supposed to have this mass per unit time as mass per second. So means we are supposed to convert this 1,300 ton times 1,000 kg in this case, so that we obtain kg per second. The 7.5 hours to seconds is gonna be times 3,000. 1 hour is 3,600 seconds. So meaning to say this is what you're going to have at the end, which is gonna be 48,148. So that's 48,148 in kg per second. So we are obtaining the mass per second in this case. All right, so this is the mass or the load mass per second in this case, which is the mass per second. So this is simply our load mass per second, which is given as 48,148. These conversions, you're supposed to write them on your paper. You're not supposed to erase them. It's marked. These are marks that you are going to be also awarded on conversion of units. You're not supposed to write this aside. You're not supposed to erase this. You're supposed to indicate this part on your calculations. All right. The discharge of coal after top dead center takes place at 43 degrees. You're given the discharge theta, which is 43 degrees. The discharge is the angle in degrees. And also the efficiency of drive, which is 76%. So we have got the efficiency of 76%. So that was the information that we're given. Then we are asked in this case, calculate the following. 3.1, the diameter of the head pulley. So how are we going to calculate the diameter of the head pulley in this case, the diameter of the head pulley? Remember what I referred previously when I was talking about the issue of velocity. When I said the velocity that we had, it was a mistake, it was an error on the typing there, because if you are to check now, because we have this velocity, we can calculate the diameter from we can calculate it from the formula for velocity. Remember, our formula for velocity, it states that the velocity is equivalent to the square root of the gravitational acceleration times the cosine of theta, which is the discharge times the radius. So from here, we can calculate r, which is the radius, since we understand that the diameter is equal to twice the radius. So the diameter is equal to twice the radius. That is 2 times the radius. In this case, is 2 times the radius. So meaning to say, we can calculate our radius in this case. Then we used to calculate the diameter, having our velocity in meters per second from that conversion that we talked about, that I was saying this one was just a mistake. It was supposed to be meters per minute. We convert to meters per second, velocity in meters per second. So we're gonna substitute our velocity meters per second, 1,333, which is equal to the square root of the gravitational acceleration of 9,81 times the cosine of the theta, the discharge in this case of 43 degrees. So you're gonna have in degrees, then times the radius, which is the one that you're supposed to calculate. So how can we calculate the radius? We can square both sides to remove the square root, since the radius is inside of the square root. So that means we are going to remain with 1,333 squared, which is equal to 9,81 cos 43 degrees, all right, times the radius in this case. So in order for you now to calculate the radius, since we are multiplying, you can simply divide in this case by this whole part, so that we remain with the radius in this case. So meaning to say, we are going to divide by 9,81 the cosine of 43 degrees both sides. So here we're going to divide by the cosine Okay, we've got 9,81 here, 9,81. Do not forget the 9,81. So we've got 9,81 cos 43 degrees. So that means this and this part will cancel. We will remain with the radius. So our radius in this case was going to give us something like 0,248 to 3 decimal place. That was going to be 0,248 in meters. The radius measured in meters. So having your radius, it means you are going to obtain now the diameter. The question was not about the radius, it's on the diameter. So therefore, our diameter in this case from 2 times radius, we are going to obtain our diameter as what? That is, we are going to multiply 2 times the radius, which is 0.248 meters. So that means we are going to obtain our diameter, in this case, in meters, unless you want to convert to millimeters. That's gonna be 0.496 meters. If you want to convert to millimeters, you multiply by 1,000. So that will be something like 496 millimeters in this case. All right. So that is it on this part here. Then also on this part, they want us to calculate the total length, 3.2 to the total length of the chain. Assume that the top and the bottom pulleys are of the same diameters. So if they've got the same diameter, they have got the same radius. All right. So I talked about this. If you check the August, that was, I think, August 2023 paper, whereby we have to consider this time to say we are dealing with length, which is true. All right. So let us just try to have this one, 3.22. You're considering the total length of the chain. So this chain is supposed to be of this nature. This is where we have our chain. All right, so this is the layout of our chain in this case, whereby you are to consider here as a circular part and also here having a circular part. So what it means, the chain is being affected by a half circle on top here. It's covering half circle on top, and also it's covering half circle below. So remember, the length of a circle, the perimeter of a circle is 2 pi r. But now you are considering half of a circle. So it's gonna be pi r, which is the length of this point to this point. The length of that semicircle is gonna be pi r. On this side is gonna be pi r. Then from this point that is remaining up to this point here, there's a distance, which is the height, in this case, like a cylinder. So this height is our center, which is C in this case. We are referring to C in this case. So then we also consider, which is the same as this part also, whereby we have got a C. So the total length, I said, is gonna be 2C. There are 2 of them on this both perimeter. We're talking about the length of the chain, the distance right round the chain. That is the perimeter. So you're gonna have C plus C, which is 2C plus pi r plus pi r, which is gonna be 2 pi r. There are 2 of them. So we end up having a complete circle at the end, a half circle plus a half circle. That's a complete circle. All right. So we have all these values. See, here it's 90. So it's gonna be 2 times 90 plus 2 pi r, which is the radius. In this case, we calculated, when you're calculating the diameter here, our radius was 0.248. So we're gonna have 0.248 in this case, 0.248. So we are going to have the total length of the chain in this case, and the total length of the chain was going to be 181,558 meters. So approximately, to the nearest whole number here, our length is going to be 182 in meters. So that is, say, our length is equivalent to 182 approximately to the nearest whole number. That's what you're going to have. All right, so that is how you calculate the length of the chain. The total length, you are considering the top part and the bottom part having same diameters. So they have the same, it's the same circle, like we are just having the circle, the same part. So the radius is also the same. Then 3.22, they're asking us to calculate the number of buckets per second. 2 marks for that, to have the number of buckets. Which formula is it that we use to calculate the number of buckets? We need the chain speed. On that part, we're gonna need the chain speed and the spacing. All right, so that's 3.23. So the number of buckets per second, number of buckets per second in this case. All right, it's going to be the chain speed in this case, which is the velocity. So you're gonna need the chain speed in meters per second, then over the spacing. So you're gonna need the spacing of buckets per second in this case. So you're gonna have the spacing, which is measured. The spacing is in meters in this case, all right? So substituting these values, we've got the chain speed in meters per second. Remember, on our conversion part, we obtained our chain speed here, meters per second, 1,333 and so forth in meters per second. That is this velocity, the speed. So you're gonna have 1,333 in this case in meters per second over the spacing in meters. So our spacing here is supposed to be in meters, which is 0.7. Our 0.794 in this case, 0.794 from our conversion that we had before. So this is gonna be 0.794 in meters. So that's we're gonna have the number of buckets per second, which is 1,679 buckets per second. So you're gonna have bucket there per second, or just bucket per second. All right, so that was our question 3.23. Then let us check the other part. Now they need us to calculate the mass conveyed by each bucket. The mass conveyed by each bucket. So we need the load, like the mass per bucket, the load per bucket, the load per bucket. So if it is the load per bucket or the mass per bucket, we're gonna need the load mass over the number of buckets, because it's by each bucket. So we're gonna divide by the number of buckets that we have, definitely per what? Per second. All right, so that is what we are going to have, 3.24 in this case. So we said the question is asking us to calculate the mass per bucket. So we're gonna say the mass per bucket. In this case, we are going to need the load mass per second, which is the load mass. So we're gonna need the load mass per second over, for us to have bucket here, we must have number of buckets per second. So we're gonna need number of buckets per second. So it's if you do not know this part, you can simply tell the formula, what is it saying per bucket? It means this one divided to this, mass divided to number of buckets. The load mass in kg per second, we have the load mass in kg per second. Remember, the load mass here, we said it's 48.148, the load mass in kg per second. So that is the value that we are going to take. All right, so we said we're gonna have 48.148, which was in kg per second, over the number of buckets per second. This is the one that we just calculated now, the number of buckets per second. This one, remember, we calculate the number of buckets per second, which is 1,679 buckets per second. So we're gonna have 1,679, that is bucket per second. All right, so if we divide these two, we are going to obtain something like 28,677, which is the mass in kilograms per what? Per bucket. In this case, it's gonna be the mass per bucket. So you have to be careful. You have to be careful. Your formulas, deal with your formulas, manipulation of formulas from the information that you are given is very, very important. All right, so you're gonna consider 3.25, which is the last part of our question, whereby they need us this time to calculate the driving, all right, the driving motor power. All right, so how are we gonna have the drive motor power? Remember, the power in this case, the motor power, we are representing to the power that is the input power, that is our Pin. The Pin is the power of the motor in this case. So in order for you to have the power of the motor, you are supposed to also consider the efficiency, because we've got efficiency here. All right, so let us consider the efficiency and the output power. So let me just have it aside here. Let me just have it aside here. All right, so we need to calculate the power of the motor in this case, 3.25. We need to calculate the power of the motor. And I say the power of the motor simply represents Pin. And the only way for us to have Pin is from efficiency, since our efficiency is given as P out over Pin times 100%. So the efficiency we have, remember, we are given an efficiency of 78. In this case, it was 76%. So we're gonna have a 0.76. But what about P out now? Where are we going to have this? Because as we are supposed to calculate P in, which is the P motor in this case, by calculating P in, we are calculating P motor in this case. So P out is the power that is to lift the load against gravity. So that's PG. P out, that is our PG. Then P in is the power of the motor in this case. So when you're asked to calculate the power of the motor in this case, they are simply asking you to calculate P in, but we need PG, which is our P out. And P out, where are we going to take this P out from? Our P out, which is equal to PG. We're going to take this, since it is the power to lift the load against gravity, we're going to use mgh, which is the mass in kg per second, times the gravitational acceleration times the height, that is in meters in this case. So if you had to check, we have the mass per second. We've been talking about this mass, the load mass per second here, the load mass per second, the gravitational acceleration, but we do not have the height in this case. So the height is taken from the L that we calculated here. From the L that we calculated, it follows that the height is equal to L over 2. So that's 182 over 2 in this case, which was going to give us 91 meters. So we have the height. So we are going to use this information, the mass per second, in this case, kg per second, and which is 48.148. So this is 48.148. All right, 48.148. So we've got 48.148 times the gravitational acceleration, 9.81 times the height, which is taken from L over 2, that's 91. So this is going to give us P out, which is our PG in this case. Our P out is our PG, that is 42,982,201 in watts. So you can even convert this to kilowatts, which is gonna be 42,982 in kilowatts. So we have P out in this case, which is PG in this case. And we can substitute this information because we want to calculate the power of the motor, which is our P in. So to calculate P in, which is the power of the motor, we simply need our formula. We said efficiency in this case, which is 76%, divided by 100 is gonna be 0.76, which is equal to PG, that is P out in this case. So we've got 42,982, which is kilowatts, over the power of the motor in this case, which is our P in. P in, that is the power of the motor. So you can play around your cross multiplication, then you divide by 0.76. At the end, we shall have our P motor as 42,982 divided to 0.76. Remember, this is in kilowatts. So our power also of the motor, which is our P in, is going to be in kilowatts. So our P in, or P motor in this case, in kilowatts, is going to give us 56,555 in kilowatts in this case. So that is it. That is how we play around with this information. We have to play around our formulas. Manipulating of our formulas is very very important to the favor of what you are supposed to be calculating, to the favor of what you are supposed to be calculating in this case. So that is our relationship. So if you check, it's a repetition. Check the question paper of August 2023. Check August 2023 exams, then you see that it's just a repetition. Sometimes they give you the information listed, like they just want to, like it's a different type of a question, but having the same question that they just give you direct as a sentence. Yeah, they try to give you information to say this is what we have on this part and so forth and so forth. This part does not even affect. List your information properly. That is what is important. Know the conversion of units, to the basic unit that is needed on your formula. So you can actually obtain the total of 15 marks on such typical questions. If you check, mostly 15 marks. So you also need to know how the arrangement of your syllabus is given, so that when you're revising, you know how many marks are you working with from a particular topic or from a certain topic. But that was the whole idea there. That was the whole idea that we were working with. But for now, we shall see more as we are revising.